Bismillahirrahmanirrahim. In the name of God, the most gracious, the most merciful. Welcome to a live A-level physics lesson. So this is A-level physics year 1, and we are going through the edXL textbook. You can find the textbook on Amazon, let's take a look at what the front cover looks like. And while that's loading, okay, here it comes. So this is what the textbook looks like. Pearson edXL A-level physics. We are going through the year 1 section of it. So Bismillahirrahmanirrahim. First section is an introduction, and we're looking at just some prior knowledge that you need to know before you go through to the next parts of the chapter. So Bismillahirrahmanirrahim. In the name of God, the most gracious, the most merciful. Let's take a look at question number 1. So it says a man walks 1.6 kilometers in 20 minutes. Calculate his average speed. First thing we need to know is what is the formula for speed. So speed is equal to distance divided by time. If you haven't memorized this formula already, then you need to memorize this formula. Next thing we need to know are what units should we use. So it's not really told us what units to use for speed, so let's just go with the standard of meters per second. Meters per second. So that means we need to know the distance in meters, 1.6 kilometers. That can be changed to times by 1,000. That's 1,600 meters. Then let's divide by time. Time we'd really want to have in seconds. So since there are 60 seconds to every minute, then let's change the minutes to seconds by doing 20 times 60. And that would be 1,200. And then you can type this into your calculator, and you should get, let's do that now, 1,600 divided by 1,200. So that's 1.3 recurring. So 1.3 recurring, and it's meters per second. And next one now is a sprinter runs 200 meters at an average speed of fraction. Power 1 we can just ignore, so it's meters per second. Calculate the time taken for her to complete the distance. Let's start with the formula we had before. Speed equals distance divided by time. You can either rearrange this right now. You could take time to the other side as a times, and speed to this side as a divide. So you'd end up with time equals distance divided by speed. I prefer to do my rearranging at the end rather than at the beginning, so I prefer to put the numbers in. So let's put in the numbers. We've got 200 meters, that's the distance, so that can go here. And then we've got the units for the speed is meters per second. So the important thing is that meter and meter per second, that is consistent, that matches. If that didn't match, then you'd have a problem, but just make sure it matches. Meters and meters is the same in both parts. Meters per second, so it's 8 is the number, so we can put 8 here for speed. Now let's rearrange for time. So we've got divide by time. We can take the divide by time. If we want to take the time to the other side, then it would have to change from divide to a times. So let's move the 8 a little bit across, and let's put times by time. And then normally we'd get rid of the line, the divide line, but here let's keep it for a second because now we want to move the 8 to the other side. The 8 is being timesed, or the 8 is timesing, so on the other side it would be divided by. On this, the units on this depends on what units we fed in, so that's per second, so it would be seconds. Okay, next one is acceleration. Let's have a read of this one. So acceleration can be calculated by dividing a change in speed by the time taken. State the unit of change is normally written as a triangle here, change in speed divided by change in time. So it all depends on what units we're feeding in. So if speed is in meters per second, and we are then dividing by time, which is seconds to the power 1, then what we need to do is just treat that as algebra. And let's just say, what would happen if I took m meters plus ms to the power minus 1 divided by s to the power 1. So m would just stay as m. S to the power minus 1 divided by s to the power 1. So remember, when you're dividing, you take away the powers. So it's minus 1, take away 1. We're taking away the powers. So minus 1 take away 1 ends up as minus 2. So you would end up with s to the power minus 2. And that's written as, or said, meters per second or meters per second squared. Okay, and then the last one, we're talking about question 4, speed and vectors. Speed is a scalar quantity, velocity is a vector. Explain the difference between the two. So let's get a grid. This one looks pretty good. And what you want to try and understand here is that with velocity, we're just showing a little bit more information. So we could have, if we start, let's say at the origin 0, 0, then if we do a vector for, let's say, how the object is moving, it's moving 3 squares up and then 3 squares to the right, 2 squares up. So whether we write that as a vector or whether we write that in words, 3 squares to the right, 2 squares up, what we're describing there is not just how much it's moved, or how it's moving 3 squares up, 3 squares to the right, 2 squares up per second. So we've got what's called magnitude and direction. So here we can clearly see the direction, and we can also see the magnitude. But with speed, it's more just about the magnitude. So if I was to use Pythagoras on the 3 and the 2, I would get 3 squared plus 2 squared. Or if I was just to measure that line, let's just suppose I was to measure that line with a ruler, meter. So what's the difference between the vector and the speed? So this is called velocity here, when we're doing it as a vector. So here we have much more information. We have the direction, we also can see the length of the line. Whereas when we're doing it as a speed, we're only really talking about the length of the line. So we're saying the speed is 3.6. What's important with velocity is that it can go backwards. So if I press the reverse button and I was to, in blue, go backwards, now I would say the velocity is minus 3. So for blue, it's minus 3 minus 2. It's going backwards. But with speed, there's no such thing as minus speed. So we would still say the speed for the blue vector is still 3.6 meters per second. So speed has no account of the direction, whereas the velocity, we can put positives if it's going one way, negatives if it's going the other. And we can also see things like angles, and there's just more information when you're doing the velocity, when you're doing the vector, which is called velocity now, rather than speed, which is just a number, and that's called a scalar. That's the end of lesson 1, the prior knowledge you need to know before you go into the chapter. Thanks for joining me. Assalamu alaikum wa rahmatullah. Peace be with you, and the mercy and blessings of God.